Assalamualaikum and good morning to our lecturer, Dr. Mat Zarafi bin Ahmad, and to all my fellow members. So for today, we will present about simulation and analysis on centrifugal pump decision motor in electric drive subject BEV 30703. And my fellow friend is Ahmad Mustaqim bin Rosli, Ahmad Aidil Akhil bin Muhammad, Scovin oleh Lawrence, Muhammad Hanif bin Lutfi, Muhammad Afikimi, and bin Muhammad Shukri. So for the first introduction, I will pass to my friend Dr. Kim to present the introduction.
Hello, Assalamualaikum warahmatullahi wabarakatuh. Okay, for our project, we choose a centrifugal pump as our project. Next, okay, this project has chosen a centrifugal pump as a model of application with using DC shunt motor as DC motor drive to run the simulation. A centrifugal pump is a mechanical device that moves a fluid by transferring rotational energy from one or more impellers or driven rotors. Fluid enters the impeller along its axis and it cuts out throughout its circumference by centrifugal force through the impeller vane tips. This project uses a DC shunt motor to run the centrifugal pump. A DC shunt motor, also known as a shunt-wound DC motor, is a type of self-excited DC motor where the field windings are shunted to or are connected in parallel to the armature winding of the motor. Next. Okay, this is a centrifugal motor. We have three types of impeller. So first one is open impeller type. Second one is semi-open impeller type, and third, enclosed impeller type. Okay, next. Okay, the proportional integral derivative PID controller. A proportional integral derivative controller is a generic control loop feedback mechanism widely used in industrial control systems. A PID controller attempts to correct the error between a measured process variable and a desired set point by calculating the and then outputting a corrective action that can adjust the process accordingly. The PID controller calculation algorithm involves three separate parameters: the proportional, the integral, and the derivative values. The proportional value determines the reaction to the current flow, to the current error. The integral determines the reaction based on the sum of recent errors, and derivative determines the reaction to the rate at which the error has been changing. Okay. That's all from me. I will pass to the next presenter.
Assalamualaikum and hi. I will doing for the problem definition. Next. Problem statement. Centrifugal pump are hydraulically operated machines characterized by their ability to transmit energy to fluid. Their main purpose is to transfer fluid through increase of the pressure, but the main problem of centrifugal pump when there is too much pressure in the pump, the load at the shunt motor will be high and there will be more torque and more current. When there is the current used more, the major problem will be on the motor. This is because the inner coil motor eventually will fail to work. Next. So as our objective, we want to control the motor on a suitable speed, to have a controller speed on the motor, and to have a long-lasting motor for the centrifugal pump. Next. As assumption and limitation, the system needs to be used proportional integral derivative controller, PID controller, to prevent the current to peak. And the current will be monitored to get feedback from the system. The main of our project is to control the speed of the propeller into RPM to get the suitable speed. I will pass to my next presenter. Thank you.
Okay, hello, my name is Coben Ole Lawrence. I will present about the issues related technology in electric drive. Okay, the first issue is the electric vehicles. Electric vehicles are more fuel efficient, require less maintenance, and do not pollute the environment. Electric vehicles rely heavily on finite battery systems, which limited store capacity. As a result, steps must be taken to reduce the amount of energy stored in batteries and to make better use of it. The most suitable DC motors are those with separated fields because they allow torque and velocity to be adjusted separately using the armature and field currents, providing you more control options. Okay. Electric vehicles also consumption is significantly influenced by the motor type and control system utilized. In the electric vehicle business, both DC and induction motors are being considered, with the DC motor type being a viable contender for usage in electric vehicle applications. Okay, so next. Okay, for analysis for solving problems, okay, the first one is DC motors. DC motors need to be utilized in conjunction with the right load. This is important for brush conductivity on the commutator as well as current density, since it allows the brushes to stay lubricated when touching the commutator when under load. Carbon brushes can quickly wear down if the applied load is uneven and the motor's brushes are of poor quality, resulting in carbon dust buildup inside the motor. The commutator bus may be irreversibly damaged as a result of this issue. An excellent carbon brush can help you figure out which brush grade is suitable for each of your applications in order to deliver the complete current density at the point of contact and minimize early brush wear. It is also necessary to maintain correct consistent pressure on the brush of the commutator. Next. Okay, for PID controller is one of the system core process, and it can control the speed of a DC motor. There are additional issues with performing the algorithm, such as selecting the incorrect algorithm. The choice of a control algorithm is critical for successful process control. It can make it difficult to keep track of set points. We can begin by simplifying the job and resolving the problem in bulk, in example, the entire system. During a shutdown, the modifications are made. When switching algorithms, maintain the control output constant if modification.
Assalamualaikum and hi. Okay, today my part is methodology. Okay, next. Okay, first of all, block diagram consists of DC supply, PID, DC motor, load, and encoder. Okay, next. Okay, this is a flow chart, same like block diagram. Next. Okay, for the system explanation, first, DC motor are used extensively in industrial variable speed application because of more demanding speed torque characteristic. This system is developed a simulation-based variable speed DC motor drive for a small-scale application. Okay, the second one is the appliance that use is centrifugal pump. This system consists two major parts, which is DC shunt machine and speed loop control (PID device). The PID controller is used to control the speed of DC shunt motor. Initially, DC drive were used for variable speed control because they could easily achieve a good torque and speed response with high accuracy. A DC machine is able to produce a torque that direct the motor torque is proportional to the armature current. The armature current, the torque can thus be controlled directly and accurately. Okay, next. Okay, this is a circuit. We have two circuits. First, circuit with PID controller, and the second, the circuit without PID controller. Okay, next. Okay, for working principle, based on the application, for our application, we choose the centrifugal pump motor machine, the normal operation of the motor without PID controller, and the operation of the motor that run with the attachment of a control device, the PID controller. The DC supply that is directly connected to the motor input will go through the field coil and armature coil. Thus, will give the specific result of torque, armature current, field current, and the current motor speed. The PID controller that is connected to the switching component in the buck converter will receive the latest feedback of motor speed to control and will synchronize the motor speed. The PID controller will react depend on the load that have been received by the motor. The load is considered by setting up the speed reference. Two different values will be obtained with two condition circuit, with PID controller and without PID controller. Both of the result will be different because one circuit is reaction with PID controller is upon the speed reference and the feedback motor speed, and another circuit is not connected with any PID controller. Okay, next part, and I pass to my friend.
Hello, hi. For my part, I will explain about the circuit simulation result in this discussion. Okay, for the circuit simulation, as you can see on our right is the circuit without the PID controller. As you can see, the circuit without PID controller is a normal circuit which doesn't have any control device. So the motor is actually can't be controlled. So when the motor can't be controlled, the motor merely can get damaged. So if so the motor can easily get damaged if they're always having a high torque and high amp on the motor. So in the left peak, you can see it's the circuit with the PID controller. The circuit is attached with the PID controller, which is when the motor speed is below the safe consumption range of speed, then the PID will receive the feedback of the motor speed and it will synchronize the motor speed by keeping the motor speed in the safe range of consumption range. So there will be no high current or high torque. So the motor can lasting long the motor quality and not having damage. So for the next slide, you can see the result of simulation circuit with PID controller. This is the result with the circuit with PID controller, which is referred to the left peak. As you can see, the motor feedback speed is 1750 RPM, which is constant, and the input voltage is 224 volt, and the input current of buck converter is 13.27 amp. So the field current is 1.131 amp, the measured current is 12.57 amp, and electric torque is 17.55 Newton meter, and the speed is 1534. So as you can see over here, the waveform over here. So for the second is the result simulation circuit without PID controller. So as you can see, the voltage is same, 240 volt. Input current is 12.32 amp. So you can see the field current is high and the armature current is at the range and considered high also. And you can see the electrical torque. The torque is very high, which can cause the damage to the motor if it frequently having a high torque consumption. And the speed range is below the safe range consumption, which can cause high torque and high amp. So this is the result of the waveform. Okay, for the discussion, from the simulation, the motor circuit with the PID controller and without the PID controller is constructed. The proportional integral derivative controller function as a device that receives the feedback signal from the motor output, which is the motor speed, and will encode the receiving data to synchronize the motor speed for a better motor operation performance to avoid any damage upon the motor. This simulation system also shown that the current and torque really decrease when the PID controller is attached with the motor. Hence, it can reduce the problem of the motor damage. The waveform result and the table result also shown that the difference between a circuit that is operated with PID controller and a circuit that operates without the PID controller really had a different gap between them, such as the motor speed, the current and torque. Okay, so for the conclusion is the simulation was able to control the motor to a suitable speed. This can be proved when the simulation changed the value each time the load changed. This means the centrifugal pump able to control the DC shunt motor at a suitable speed based on the load given in this project. The controller speed has been added to the simulation. This can be proved when the value for the speed in simulation change every time the load value change. The speed control is very important because it is used to avoid the motor runs slower or faster than the suitable speed. This simulation also able to make the centrifugal pump motor can be used for a long period. It is because the speed controller that used can make the motor last longer. The performance of efficiency for the motor may be dropped, but since there is a speed controller to control the speed with the suitable speed, the dropping process will be solved. So this is our reference. The reference of PID controller. For the one is PID control made easy by the MATLAB, and the second is learn everything about centrifugal pump, which is the article, and the third is useful information on centrifugal pump, which is about article also, and DFT implementation in MATLAB. This is in YouTube by Shri Krishna. Okay, that's all from us. Thank you.